Alright, we're back, and I don't know if you can hear this, but they have a drill going on right outside the window, so I apologize if it's a little bit noisy. I will speak up a little bit so I can hopefully shout over this drill. We got a few more examples to look at, okay, and let's start with number 7. If you have 3 terms in the numerator divided by some term in the denominator, the process is the same. Break it up, do 3 division problems. And what I suggest is that for 7 and 8 that you turn off the video right now, try to do these yourself, and then turn the video back on and see if I'm doing it the same way that you are, if we're getting the same answer. Okay, so I'm going to do number 7 now. I'm going to take each term in the numerator and divide it by the denominator. So each of these gets divided by w squared. And now I just do dividing monomials. When you divide monomials, the 9 is going to stay the same. Keep the base, subtract the exponents. So w to the second. Now this will just be 3w to the first, or 3w. Now what happens? W squared divided by w squared. If you subtract this, you get w to the 0 if you subtract the exponents. Well, anything to the 0 is 1, and that should make sense because w squared and w squared are the same number. So if you take a number divided by itself, it's just a 1. So this is not 0. It doesn't get canceled out. What happens is it reduces, and we have minus 1. You have to put the minus 1 there. If you leave it blank, if you say 9w squared plus 3w, it is wrong. You have to have minus 1. Okay, that's a good example here. Now, number 8, 8q to the second minus 32q to the third divided by 2q. Let's break it up. 8q to the second divided by 2q minus 32q to the third divided by 2q. Now equals, one thing at a time. 8 divided by 2 is 4. Keep the variable when you divide. So q, and then you subtract the exponents, that's q to the 1. I'll just say 4q. And then this is minus 32 divided by 2. That's minus 16. Q to the third divided by q to the first. Subtract the exponents, you get q to the second. Those are not like terms. So you're done. That's it. Alright, so that's the front. Go ahead and flip it on to the back, and let's look at a few more examples. So here we go, number 9. If the area of a rectangle is 12x squared minus 18x, and the length is 6x, question is, what is the width? What is the width? That's what we need to find. Now the key to this is they tell us it's an area of a rectangle. Well, let's draw a rectangle. Now they tell us the length is 6x. They tell us the area itself, I'll just put that inside here, the box, 12x squared minus 18x. What we're missing is the width. Okay, so we want w here. Now here's the thing. We know the formula for the area of a rectangle. We'll say length times width. They're asking for width. They say, what is the width? Let's take this equation and solve it for w. Let's take the formula. This is called a literal equation. It's a formula. To solve for w, you'd have to move the L. This is L times W. Well, how do you undo multiplication? We divide. We're going to divide by L. So we get A, area divided by length equals width. We're doing this because it's easier to manipulate these variables here than to start manipulating 12x squared minus 18x and moving those things around. It's easier to move this. So we get the area divided by the length equals the width. Because now all we have to do to get the width, they say what is the width? Let's take the area, 12x squared minus 18x, and substitute that for a. So we're going to come up here, 12x squared minus 18x, that's your a, divided by length. What's the length? 6x. So we substitute that for L, and then we simplify that, and that gives us W. So to simplify it, we're going to break this up. So we get 12x squared divided by 6x. You have to take everything in the numerator and divide it by the denominator, each piece, and then minus 18x divided by 6x. So to divide this, well, 12 divided by 6 is 2. X squared divided by x to the first, subtract the exponents, you just get x to the 1, or just 2x. Negative 18 divided by 6 is minus 3. Now, x to the first divided by x to the first, when you subtract exponents, you get x to the 0, which is just 1. So what happens is that the x is reduced to 1. I can cross those out. Right? Now, it's not 0. They just reduce to 1. So what you're left with is minus 3. And that's it. So that's equal to W. That's your width. Now number 10 and number 11 are the same kind of problem. In number 10 it says, in the following rectangle, what is the shaded area? Now you have two rectangles here. You have a big one and you have a small one. We only want, though, this darkened area, this shaded area. So this is actually a good geometry problem, and we're going to do this with numbers first, and then we'll apply it to variables. If you take the area of the big rectangle, that would be length times width, which is 26 times 14. And if we work that out, you can use the calculator, we get 364. Now that's the big one. That includes all of this on the inside. Now, you also have a small rectangle. The area of the small one is length times width, 12 times 5, which is 60. Think of it this way. If you want the shaded area, if you take the big one and then you subtract out, let's take this out. Now how do I take that out? I subtract it. And if I take it out, what's left is going to be shaded. So the overall idea is that the area shaded equals the area of the big minus the area of the small, because you get what's left over. So that would be 364 minus 60, which equals 304. That is the area of the shaded region. Okay? So what's the idea? Take the big one, subtract out what you don't want, and whatever's left over is your answer. Now, in the last problem here, number 11, same idea. The only difference is now we're looking at variables. Area of the big is the length times the width. Now I'm going to write that. That's 4x times, I have to use parentheses because I'm multiplying not just by 3x, I'm doing 3x plus 8. The 4x has to multiply both of these. So we distribute, and we get 4 times 3 is 12. X times x, you add the exponents, that's x to the second, plus 4 times 8 is 32x. 32x. That's the area of the big rectangle. Now we need the small one. Length and width, 2x minus 3, and x. So area of the small equals x times 2x minus 3. Let's multiply. Now this is like a 1x, so 1x times 2x is just 2. Add the exponents, you get x to the second. And then 1x times negative 3 is minus 3x. So there's the area of the small. Okay, now, you've got the area of the big rectangle. We need to take out the area of the small so that we're left with just shaded stuff. What we have to do is the area of the big minus the area of the small. So the big rectangle was 12x squared plus 32x minus the area of the small one, which was 2x squared minus 3x. Now actually the way that I've done this is wrong. I've made a mistake. I forgot something. I have to subtract this whole area of the small. So the way I do that is I have to put parentheses. I have to subtract both of these. So now we're adding, subtracting polynomials here. So we get 12x squared plus 32x. That doesn't change. You have to distribute the minus. So this becomes minus 2x squared. It changes all the signs. Now when you do minus 1 times negative 3x, negative negative becomes positive 3x. The last step, can we combine anything? Yes, we can. We have 12x squared minus 2x squared. 12 minus 2 is 10x squared. When you add and subtract like terms, you do not change the exponents, just the coefficients, the numbers in front. Positive 32x, positive 3x. 32 plus 3 is 35x. That is the answer. That's the area shaded, 10x squared plus 35x, and that is the end of notes.